Okay, so this is the review on the periodic table. First of all, the periodic table is arranged by atomic number. It was originally done by atomic mass, according to Mendeleev, but you guys know that that didn't work out so well. So then Moseley came along and they did some more work and decided that the best way to arrange it would be by atomic number. So let's talk about what an allotrope is. This comes up a lot on the Regents exam. First of all, an allotrope is the same element, but that element has a different molecular structure, therefore it has different properties. The first two that I talked to you about were oxygen and ozone. As you can see right here, O2 has one double bond on it, where O3 also has a double bond, but also a single bond. So you can see that the structure is different and the properties are different. We don't mind breathing oxygen, but we probably don't want to breathe ozone. Some other things that make the properties different is oxygen obviously is a colorless gas. Ozone is a pale blue gas. And the boiling point of oxygen is about a negative 183 degrees Celsius. And the boiling point of ozone is about negative 111 degrees Celsius. So those are some physical properties that are different. Some chemical properties that would be different between them are oxygen obviously is less reactive, less soluble, and has a lower density when compared to ozone. Now you don't have to know those different physical and chemical properties. I'm just trying to make my point. If the structure is different, the properties are different. Another one that you see here on the right is diamond versus graphite. Diamond is very hard and it has interlocking covalent bonds. It's considered a network solid, so the bonds are very, very strong. Graphite, on the other hand, is very soft, and that's because it's arranged in sheets. The carbon bonds within the sheets are very strong, but the bonds between various sheets are weak. Now, I need you to take a moment and try to draw what I've drawn here on your page of notes. You can pause me and kind of draw this, and then we're going to talk about it. All right, so hopefully you pause me, and now we're going to talk about this diagram. A couple of things that you have to know. You have to know that group 1 is called the alkali metals. And you have to know that group 2 is called alkaline earth. And I tell you all the time, you can remember this because the short name comes before the long name. Group 17 are our halogens. And then group 18 are our noble gases. So those are the 4 groups that you need to know the names of. In the middle, you have your transition elements. The only thing that you really need to know about them is that they form colored solutions. You also have to know, but this is kind of another unit, that they have multiple positive oxidation states. So when we name or a compound involving one of these, we usually have to use a Roman numeral. And then we have the metalloids, and I've drawn them for you there. These are elements that have both properties of metals and nonmetals. Now, we need to know some other things besides that. We need to know some characteristics. So some characteristics of metals would be that they are good conductors of heat and electricity. They are malleable, meaning that they can be shaped. They are also ductile, which means that they can be drawn into a thin wire. And they have high melting points. They also have luster, which means that most of them are shiny. Okay, nonmetals then. They're going to be the opposite. I'm just going to write poor conductors here, but that's poor conductors of heat and electricity. They are dull and brittle, which means that they usually break apart very easily and crumble. They have low melting points. So you've heard me say before, you can put some sugar in a pan on the stove, heat it up, and it'll melt. You cannot do that with some salt. Another thing that we need to know about valence electrons is that they have 8 valence electrons, which is why they are considered unreactive, because they don't want to give up anything and they don't want to gain anything. The exception to that is hydrogen and helium. They only want 2 valence electrons. Something that's really important is that elements in the same group, meaning vertical column, have similar properties because they have the same number of valence electrons. Ionization energy is the attraction for electrons in a bond. And you don't have to memorize the trend. You really don't. But it does increase. So it increases from left to right. And then it decreases down a group. You can just take 2 elements in the same period, look them up in Table S, and see what the trend is. You can do the same thing in a group. Take one at the top of the group, one at the bottom of the group. Ionization energy is the amount of energy needed to remove an electron. And this also increases from left to right, and it decreases down a group. Radius is simply the size of the atom. This is also in Table S. And this changes from the previous 2. This decreases from left to right. And the reason being is due to the increase in nuclear charge, or the number of protons. So what happens is, the more protons you have, it's like having a bigger magnet, so it pulls in on those electrons, snugs them in, and brings them in closer. So that's that girdle theory. And it increases down a group. And the reason being there is basically you have more electrons. So you have more electrons, you have more shells, and you have increased shielding. By the inner or kernel electrons. Let's briefly talk about how the atomic radius versus the ionic radius, because this often comes up on the regents. Remember, let's use sodium as an example here, 281. I always ask you, look at the valence electrons. Is it going to give up that number, or is it going to add what it takes to make the difference of 8? So in this case, are we going to give up 1 or gain 7? We're going to give up. So metals lose electrons and they form positive ions. Therefore, the ionic radius is smaller. Let's look at fluorine now. Fluorine is 2,7. Is it easier to give up 7 or gain 1? Well, it's easier to gain 1. So, nonmetals gain electrons and they form negative ions. So when they gain electrons, they are bigger. And you can see this because in here we're going from 2,7. Why did I write Fe? Just saw that. Sorry. Should be F. 2,7 to F minus, which is 2,8, which is stable. In sodium, we go from 281 to the sodium ion, which is 2,8. So it should make sense. I'm going from 9 electrons to 8 electrons. The ion would be smaller. In the metal, I'm going from 9 electrons to 10 electrons, so the ion would be bigger. And for phase temperature, okay, so we're talking about solid, liquid, gas, you need to use table S. And compare to standard temperature. Which is 273. So if you look at bromine, bromine's melting point is like, I don't know, 266. It's lower than 273. So it already melted. But if you look at iodine, iodine's melting point is above 273. So if I'm at 273 and the melting point of iodine is above 273, then it would be in the solid state. So you have to use table S if you're not sure if something is a solid, liquid, or gas. And more importantly, you should be using, or I'm just going to put use table S to confirm all trends. All right, those are the notes. You now need to complete pages 35 to 40 by Monday. Remember, I'll be checking for both the notes and the questions.